Hello friends, today we will see operations on matrix. As you all know, the different operations are addition, multiplication, subtraction and division. So let's see one by one in detail. So first operation on matrix, what we are going to see is addition of matrices. So the condition what you need to check before adding any two matrices, whether they are of the same order. So two matrices which has to be added should be of the same order. Okay, if it is of different order, then you cannot add those two matrices. Say for example, say A and B are the two matrix where they have given the order. See, in this case matrix A is having a order of 2 by 2, and matrix B is also having a order 2 rows and 2 columns, that is 2 by 2. Since the order of A and B are equal, you can proceed with the addition of matrices. Okay, let's take another example where in this case matrix B is a matrix of order 2 by 2 and C is a matrix of order 2 by 3. When you check out the order is not same, so hence you cannot add the matrix B and C. So this is a condition which you need to check. That means you need to check the order. If it is of the same order, then only you can proceed. Okay, once you check the order, if it is of the same order, then you can proceed. Suppose if I say a matrix A is of this, that is, I'm just checking the general terms. So it is this, and matrix B is B11, B12, B21 and B22. So order of the matrix A is 2 by 2 and B is also 2 by 2. So now I can add these two matrices. So when I have to add these, you need to just add the corresponding element of matrix A with corresponding element of matrix B. That means first row, first column matrix, that is A11, should be added with first row, first column of matrix B. So this A11 is first row, first column, and B11 is first row, first column, element of second matrix B. So these two can be added. So you cannot add A11 with B12 because that is not the corresponding elements. If you want to add A12, it should be added with B12. Okay, that is the corresponding element. So it will become A12 plus B12. Similarly, next element will be A21, which has to be added with B21, and A22 is added with B22. I hope you are clear. The resulting matrix, order of the resulting summation of the matrix also will be 2 by 2. I hope you are clear with how to add any two matrices. Let's take an example. So the example is like this. They've given two matrices A and B. First check out the order. So matrix A is of order 2 by 3, and matrix B, it has 2 rows and 3 columns, so it is also of the order 3 by 3. Since the order is same, I can add A and B. Okay, so in order to add A plus B, just write the matrix once again. So this is matrix A plus 2 root 5 1 minus 2 3 half. So once the order is same, you need to add the element, first element of the matrix A, first element of that should be added with first element of the second matrix. So 2 is the first element of the second matrix. So it will become root 3 plus 2, 1 plus root 5. Third element will become minus 1 plus 1 will become 0. I hope you are clear. You have to just select the corresponding element and add. 2 corresponding element is minus 2. So it will become 2 minus 2, that is 0. 3 element of that is 3. So it will become 6. 0 plus half. So corresponding element should be added. And when you check the order of the summation of matrix, it will also be the same. It will have 2 rows and 3 columns. So whatever order you are taking the individual matrix, the same order will be there for the summation of the matrix. I hope this is clear. Next we shall move on to multiplication of a matrix by a scalar. Okay, so you know what is a scalar. If you want to multiply a scalar to a matrix, suppose if I take a matrix A, which is of this general term A11, A12 and A13, A21, A22 and A23. A31, A32, A33. If I have to multiply with the matrix scalar k times A, that is nothing but, what does it mean is, you need to multiply that scalar with each and every element of that matrix. So it will become KA11, KA12, KA13. Similarly, it will become KA21, KA22, KA23. So all the elements of that matrix is getting multiplied by the scalar. So this is how you need to multiply whenever a matrix is multiplied by a scalar. Suppose if I take for an example matrix A as this, which is of the order 3 by 3. If I want to find 3A, so how it will be? So it is same as the previous example. So you need to multiply all the elements of matrix A by the scalar 3. So it will become 3 3s are 9, 3 1s are 3, 3 into 1.5 will be 4.5, 3 root 5, 3 into root 5 will be 3 root 5, 3 7s are 21, 3 into minus 3 will be minus 9, 2 3s are 6, 3 zeros are 0, 3 5s are 15. So this is nothing but 3A. I hope you are clear with multiplication of matrix by a scalar. Next, we shall take an example wherein you need to find the difference. So difference, the rule is same. What you need to for the difference, what is the rule? It should be first two matrices. Two matrices should be of same order. Same order. Once it is of same order, you can proceed with the finding of the difference. So you need to subtract corresponding elements. Subtract corresponding elements from matrix A with B matrix. So corresponding elements only should be subtracted. Suppose for example, if I take this, you need to find what? 2A minus B. But I don't have what is 2A. Only matrix A is given. So if you want to find 2A, it is nothing but multiplication of the matrix A by 2. So what will happen? All the elements in the matrix A will be multiplied by 2. So it will become 2, 4, 6. It will become 4, 6 and 2. So this is 2A. So now if I want to find 2A minus B, I know what is B. So what you need to do? 2A minus B, which is nothing but 2, 4, 6. 4, 6, 2. So that is 2A minus B. That is 3 minus 1, 3 minus 1, 0, 2. So if you want to find out, subtract these two matrices, first find out the order. Order is 2 rows and 3 columns. Here also it is 2 rows and 3 columns. Since the order is same, I can proceed further. So what will happen here? 2 minus 3, it is minus 1. 4 minus of minus 1 will become plus 1. So 4 plus 1 is 5. 6 minus 3, 3. 4 minus of minus 1 will become plus 1. That is 5. 6 minus 0, 6. 2 minus 2, that is 0. So the resulting order also of the matrix will be 2 by 3 itself. I hope you are clear with this problem. Next, we will move on to properties of matrices, addition. So I hope you all will be knowing the basic properties of addition, that is commutative law. What do you mean by commutative, associative law? So commutative law is nothing but whenever you take any two matrix which is of the same order. So if I take A and B, when I add AB, it should be of the same order. Then only you can add, no? So whatever answer you get, even if you change the order, if you take B matrix first and A matrix next, even if you add, the resulting answer will be the same. resulting matrix will be the same. So that is why matrix addition has this property, commutative law. But only thing you need to remember, two matrices should be of the same order. Associative law, it is as simple as associativity law in addition, but in this case instead of taking three numbers, we'll take three matrices A, B and C of the same order, say m by n. Then when you add A plus B matrix, A and B matrix first, and then to the answer of the matrix, whatever matrix A plus B you get, with that you need to add the third matrix, and that will be equal to, when you add second and third matrix first, and then if you add with the first matrix, then also the resulting matrix will be of the same value. So this is called associative law. Now third property of matrix addition is additive identity. Identity means what? Whenever you add any number or a matrix with the same with some number, it should give the same number. So that additive identity is nothing but 0. It is holding good for matrix as well. Suppose if you take a matrix, say 2, 4, 6, 8, if you have to get the same matrix A, that is 2, 4, 6, 8, then you need to add with the matrix of same order of the matrix A, that is 2 by 2 in this case. So when you add with this, 2 plus 0 is 2, 4 plus 0 is 4, 6 plus 0 is 6, and 8 plus 0 is 8. So this is called additive identity. This is existence of additive identity is proved. So whenever you add any matrix with the 0 matrix, then the resulting matrix will be nothing but the matrix A itself. Clear? Next property, fourth property, what you need to know is additive inverse. Suppose you know what is additive identity. When you add any matrix, suppose A plus, if A is one matrix, if you add some matrix, it should give you additive identity, that is nothing but 0. So this is possible only when you take inverse or negation of that matrix, given matrix, then only you will get that 0 matrix. Suppose if I take 2, 4, 6, 8 as matrix A, if I have to get 0 matrix, that is I should get a 0, 0, what should be here? It should be then negated of that value, negated value of that matrix. So then only I can get equal to 2 minus 2 is 0, 4 minus 4 is 0, 6 minus 6 is 0, and 8 minus 8 is 0. So this minus A is nothing but inverse. It is called additive inverse of A, matrix A. But only thing you need to remember, all these should be of the same order. Next we will check out the properties of scalar multiplication of a matrix. Suppose if A and B are the two matrices of the same order, say m by n, and K and L are the scalars. If you have a scalar like this, K of A plus B, which is equal to, if you add K, if you first calculate what is K times A and find out K times B, then if you add these two matrices, the answer will be same. So that is what given, K of A plus B is equal to Ka plus Kb. Suppose if you have another two scalars, K and L, so K plus L times A will be equal to Ka. First multiply what is Ka, first find out Ka, then find out La. Then if you add these two resulting matrix, then also answer will be same. So that is what is given here, K times Aij, that is nothing but matrix A is Aij, matrix B is Bij. So all the elements of that matrix will be multiplied by K, that is scalar K, and then what they have to do is, first you need to add these two matrices and then multiply it with the scalar. That is one condition. Or you can multiply with the scalar first to the matrix A separately and matrix B separately. Then if you add these two matrices, then also you will get the same answer. That is why you have to remember K times A plus B is nothing but Ka plus Kb. Similarly, if you have two scalars, first find out what is K plus L into A matrix plus K times Aij plus L times Aij. That will be nothing but K times, if you have to, K times A plus L times A will give you Ka plus La. So it is equal to. I hope this is clear.